All right, so this is how you solve a horizontally launched projectile problem. So we're just going to practice the first day only solving ones that are horizontally launched, and then next class we will do things that are launched at an angle. Okay, it's a little bit tougher. All right, so here, right, a horizontally launched projectile, all right, is going to be one that is fired only horizontally, straight out at, we would say, an angle of 0, right? Like if I'm looking at this here, this would be an angle of 0 degrees, all right? The ball would follow this straight line path, just like the boat guy, you know, the simulation boat guy in week 1, but also at the same time, it's going to fall, okay, as if in free fall, because it is also in free fall. All right, so this is how you would look at a problem for that. So in an example, in an effort to create a cannonball-style splash, 8-year-old Matthew runs off the edge of a board of the high dive at 4.6 meters per second and falls 2.3 meters to the water below. Determine the time for Matthew to fall 2.3 meters to the water. What horizontal distance will he land? And with what speed does he enter the water? Okay, this is a very common problem, and many AP free response questions have some projectile component to them. Okay, you'll see when we get a little further. Okay, all right, so the first thing that you want to do is draw a picture, and I'm going to run out of space, but we'll figure that out. Okay, so I'm going to draw a picture of little Matthew, okay, running off the board to here. Okay, this is going to be the horizontal distance that he lands. Okay, and this is going to be the vertical distance. Okay, he's leaving here with a V naught of 4.6 meters per second. Okay, and I know that this delta y is 2.3. Okay, when I'm solving projectile problems this way, right, I'm going to solve it with my positive set down and to the right, because that keeps everything positive. In WebAssign, we need to look because they might always set up as positive. Okay, so you might have to just change the sign of the answer when you get to it. Okay, all right, so this is the most important thing in projectiles is you need to set up 2 lists. All right, your X list and your Y list. All right, so my X list, my delta X is unknown. My velocity, I'm going to call this V naught X because it's only in the X direction because it's horizontal. And the time, I do not know, okay? The acceleration is 0. You don't have to write that, but just know that, right? The acceleration in the X direction is 0. This is more of a constant speed direction. All right, here in my Y direction, my delta Y is, I'm going to say positive 2.3, right? Because I set down as positive, but if not, you're going to have to make that negative. Okay, my acceleration is going to be positive. I'm just going to use 10 for now. 10. Okay, again, that would be negative if you set it the other direction. The time I do not know. Okay, and the V naught Y is 0. This is because it's being launched horizontally. Okay, that's important. That's what makes this problem wicked easier than what's coming next. All right. Okay, so you always want to set up 2 separate lists because you're thinking of those 2 things separately. Okay, the thing that goes between both directions is always the time, right? Because the ball is in the air the same amount of time, whether you're thinking of it in the X or the Y direction. Okay, all right, so let's look at what the first problem says. Determine the time for Matthew to fall to the water. All right, so what you need to do is you need to look at these and see which one do you have the most information for, okay? So in the X direction, your only choice is basically to use this equation, okay, because it's constant velocity, okay? And I don't know 2 of the 3, which means I need to start off in the Y direction, where I know the delta Y, the A, the T, and the V naught, okay? So I'm just going to scooch down here. So delta Y equals, this is A, 1/2 AT squared plus V naught T, V naught YT. And I can put all these Y's here. Okay, this is going to go away, which makes this easier. All right, so my time is going to be radical 2 delta Y over A, which is going to be 2.3 meters over, I guess I'll use 10. Whatever, it doesn't matter. 9.8 or 10. Trusty calculator. The good calculator this time, so this will be like 2 times 2.3 divided by 9.8, okay, and then take, oh, I said I was using 10. 2 times 2.3, stupid WebAssign, 10. All right, and then I'm going to get 0.68 seconds, okay, which seems pretty reasonable. The times are usually pretty small. All right, so 0.68 seconds. Okay, now I know that. Okay, so now usually what happens is you'll jump to the other direction and find the next thing that they'll ask you, which let's see, it probably is, yes, horizontal distance from the edge of the board. That's the delta x, okay? So for the second one, you're just going to use delta x equals v naught xt, because that's the only velocity that there is, all right, which is 4.6 meters per second for 0.68 seconds times 4.6 is 3.1 meters. Okay. And that's also going to be positive, right? Because I've set to the right as being positive. Okay, now the trickier part on this one, slightly trickier, is the speed. Oh, I should have added this first then. Okay, I might have to go back and reorganize these slides. Okay, so the speed that he enters the water, all right, is actually a two-directional speed, right? So if you think about, he's coming off like this, right? When he hits the ground, he still has that same v naught x that he had before, right? Because he has that the whole time, because that doesn't change, okay? But his y velocity is getting bigger. Oh, yeah. So I'm going to call that v final y, because that's different. Okay, you can call that v final x too, it doesn't matter. All right, so what I'm looking at is I have a v naught x this way and a vy this way. All right, and then those are going to combine to make the total v final, or the final speed. Okay, and they say speed because they don't really care about you figuring out the direction at this point. Okay, so I do need to know how fast he's moving as he enters the water. All right, so if I just look at his y direction, I can do vf equals at plus v naught, and these are all the y's. Okay, that was 0. So v final y is going to be 10 meters per second squared, and he was in the air for 0.68 seconds. Okay, so he's going 6.8 meters per second. Okay, so this is 6.8. Okay, and my v naught was still 4.6. That has not changed. All right, so then you just have to use some little bit of Pythagorean theorem to throw that together. All right, so if I think of it this way, I might redraw it like this. 4.6. Okay, and then that resultant speed would be like this. Okay, so 6.8 squared plus 4.6 squared, square root would be the final. Squared plus 4.6 squared. Oh, I'm so happy to have the good calculator. So much easier than using the phone. Okay, 8.2. So I'd say 8.2 is his final speed as he enters the ground. Okay. All right, so that is how you do a horizontal problem. Sometimes they'll ask you to find this angle also. Okay, this one did not. I'm not sure on WebAssign if it did, but then you can just, well, I kind of drew this triangle wrong then. Right, they usually ask for this angle like below the horizontal. Okay, I'll look on WebAssign. If there's one like that, I'll make another little video of it. Okay, and then you would just use tangent, or at this point you could use sine or cosine also, it doesn't matter. Okay.